Okay, as we go through these and we learn how to solve these equations, I want you to keep something very firmly in your mind. When we're working with equations, that means equals. And we can look at equals like a balance. When two things are equal, they are perfectly balanced. Neither one of these sides is dropping down any lower than the other one. We have to maintain balance at all costs. Now, just like we saw in the previous video, whenever we did 5 times 3 equals 15, and I divided both sides by 3, and then that gave me 3 divided by 3 is a 1. So then I had 5 times 1, which is 5, equals 15 divided by 3. This was the check, or the forward and backward of each other. I could do that as long as I did something to the same thing to both sides of this equation. This is true in solving any equation. We're going to use this same idea. We can add anything we want to as long as we add the same thing to both sides. You have to maintain balance. Think about, this scale balance here. We could put an extra weight here on this side as long as we put the exact same weight over here to keep that in perfect balance. This is called the addition property of equality. Let's see how it works. Here we have a problem that says solve a plus 5 equals 23. And now you could probably look at that and tell what the answer should be, but we're going to do this using the proper procedure so that whenever you get to more difficult problems, you'll know what to do. Okay, our goal here is we want to get this letter alone. We want to end up with something that says a equals something so that we can find the solution to this problem. Well, right now, a is not alone because it has plus 5 attached to it. So what would be the opposite of adding 5? Well, that would be to subtract 5. I can do that as long as I maintain balance and do it to both sides. So now, over on the left-hand side of the equals, I have a plus nothing, which is just a, equals 23 minus 5. Well, 23 minus 5 would be 18. So I'm saying that my solution is 18. Let's check that to make sure. We should be able to check any of these problems by placing what we think is the solution in place for the variable. So I'm saying a is actually 18. So if I add 5 to that, that should be 23. Well, 18 plus 5 is in fact 23. So this is a true statement and it checks. Let's try to do another one here. Here we have 7 equals y minus 2. And again, you could probably do this one in your head, but we're going to go proper procedure. We want our y to be alone so that we can figure out what it is. So what would be the opposite of subtracting 2 from y? Well, that would be to add 2. And because of balance, we have to add it to both sides so we maintain that balance. Now, over here on the left-hand side of the equal sign, we have 7 plus 2, which would be 9. And then over here we have y minus 0, because minus 2 plus 2 is 0. So we just have y on the right-hand side. That tells us that our y is actually 9. Now again, we can always check these, and we should check them, especially at the beginning, until you get really comfortable with what you're doing. We should be able to replace that y with a 9, and it should make a true statement. So does 7 equal 9 minus 2, which is 7? Yes, it does. So that checks.